Cool. We've got few people coming in now. So hello, everyone. Welcome to today's webinar. We'll just wait for a little while to just let the numbers pick up a little bit, and then we'll start. Feel free to introduce yourself in the chat or anything, and just like let us know where you're coming from, and maybe start a little conversation, see what goes on. Cool. I'll give it a couple more seconds and then we can get cracking with it. Cool. Are we all good to start? Yeah.
Yeah, all good. Yeah.
Cool. So hello everyone, and welcome to today's webinar, Upskilling for Teaching Maths Mastery, and it's with Ian Davies and Caroline Hamilton. So I'm just going to pass over to Caroline now, and she can take it away, and I'll keep an eye on the chat. So any questions, I will field those for you.
Thank you, Cassie. Thanks very much. Welcome, everyone. Thank you for joining us this evening for this webinar. Before we do proper introductions and everything, I'm just going to pop a link in the chat. And can you just make sure that you've downloaded this algebra tool, because we'll be using it during my little section. And then also, if you could make sure you've got a pen and paper, that'd be great. You might just need to jot down a couple of things during the first section. So welcome, my name's Caroline Hamilton. I'm the Managing Director of White Rose Maths, and I also co-authored and series edited the textbooks with Ian Davies. I'll just let Ian introduce himself as well.
Hi, thanks, Caroline. Yeah, my name's Ian Davies. I was the co-author and series editor with Caroline, and my job is one of the heads of learning at White Rose Maths, and I lead the curriculum team.
Great. Right, so we'll get started then. We're just going to go through a little bit about how the textbooks can help improve subject knowledge first, and just a bit of an overview of the series in case you're not aware. Then I'm going to take a look at using algebra tiles to support pupils' understanding, and I'll show you some examples from the books as well, how they can help teachers that are maybe familiar with algebra tiles. And then Ian's going to take you some developing geometrical reasoning as well. And there's some exciting activities in that section. So I'm looking forward to that as well. So we'll get into it, and just a reminder of what is available. So book 1 has been released in March 2021. Book 2 came soon after, and book 3 is also now out as well. So the whole series is out for the Key Stage 3 textbooks, and we'll be dipping in and out of through this session, so you'll be able to see examples from all of them. And just a little bit about the books is we feel that they provide a really comprehensive learning journey, and they help pupils build this culture of deep understanding and competence in maths. So you'll notice, if you have seen them or what you see of them today, is we're really promoting that understanding. There's not any tricks in these books. Everything is really explored in detail to make sure pupils understand where things are coming from. They fit perfectly alongside the free White Rose Maths secondary schemes of learning, but they can also be used alongside other material as well. So if you follow a different curriculum, don't worry, you'll be able to use these books because they cover the Key Stage 3 national curriculum. And they're very much designed to support a mastery approach to teaching and learning. And as I've just said, they cover the national curriculum for Key Stage 3. And we're going to have a little look at this mastery approach now. So some of you may be quite familiar, some of you may not. So don't worry, we'll go as fast or as slow as you need through this webinar. So one of the first things that is quite unique about everything we do at White Rose Maths is that we've broken content down into small steps. And here's a little extract from our schema learning. And you'll notice that this is on equality and equivalence. And often if you're following a scheme or some objectives, it might just be quite vague. It might just say solving equations, for example. Whereas what we do at White Rose Maths is we break everything down so that no matter where you're coming from as a teacher, whether you're really experienced or new to teaching, you're not going to miss any details that pupils need. So here we can see we're highlighting that before we start solving equations, they need to understand the meaning of equality, understand the use of fact families, which is something they learn at primary school. And then further on down the list, again, before they start simplifying expressions, they need to know what is meant by like and unlike terms and the understanding of equivalence. So we really break the curriculum down to make sure nothing is left to chance for our. And just to show you how this translates into the textbook, here's the first two steps here. In the textbook, we can see that these are covered in the chapter called Using the Equal Sign. So you can see where the small steps correlate in the textbook, and this happens all the way throughout the series. Some chapters might just cover one small step, some might cover three, some might cover two. It depends on how much time we feel the small steps need pupils' learning journey. So that's a little bit just about how it's broken down. And this in itself, we really feel helps improve teachers' subject knowledge. Or if you're a non-specialist coming to teach some lessons, it's going to help you know where to start and where you're moving to. And then secondly is just briefly touching on the mastery approach to teaching and learning. Obviously, there's a lot to this and we could probably do 2 hours just on this, but we haven't got time for that. So I just want to highlight the concrete pictorial abstract approach, because this you will find is really evident throughout the whole textbook series. And what we mean by that is using concrete manipulatives, such as here, cubes, to represent mathematical ideas. We can use pictures, so in this case a bar model, again to represent the same expression here, but then also we could represent it abstractly using numbers, letters and symbols. So here we've got this, we are representing 4D plus 3 in 3 different ways using concrete, pictorial and abstract representations. And this is what it looks like in the textbook. So every single chapter has a models and representations section. And this gives teachers ideas on what would be useful for this topic. So here we're forming and using expressions. So we might want to be using function machines, cubes and counters, algebra tiles, bar models, but also we could represent using words and symbols as well. And we're just going to focus the first section of this webinar on algebra tiles. So to help me out before we get started, to give me a sense of what pace to go at, would you mind just popping in the chat, have ever used algebra tiles before? If a lot of you have, I might go a bit faster, but if people don't know what they are, I'm going to go a bit slower. So if you just put a Y for yes or an N for no, it'll give me a good idea. Okay, so generally it's looking like a no. A few people have had a little go with algebra tiles, but not too much. So that's really useful, thank you. And we'll get going now and have a look at how we can use algebra tiles to help pupils really understand algebra. And that's key. This is about just getting the answer. It's about pupils exposed to what is going on when they start manipulating algebraic expressions or equations. So first of all, let's just explain what they are. And if you are using these with a pupil, definitely don't skip this step. So we've got 3 tiles here, and we're going to start at the right-hand side with the yellow square tile. And this is a 1x1 square. So it's got an area of 1. So this tile represents 1 whenever we're using it to manipulate expressions. The green tile has dimensions 1 and x. So this has an area of x. So this is what we call our x tile. And then finally, the blue tile has dimensions x and x. So we call this tile the x squared tile, okay? And obviously we could use different letters if we wanted to. I'm just using x for this example. And the reverse of the tiles give you the negative version. So we've got negative x squared, negative x, and negative 1, okay? So when we're using the tiles, that's how we're going to label them, and that's how we're going to use them when we're looking at expressions that we'll do in a little minute. And here's an example of where we have used algebra tiles in the textbooks to talk us through some examples. So in this part of the book, we are simplifying expressions. C in part B and part C there, we've shown exactly how you could use algebra tiles to do this. So if you were coming to use the book and you'd never used them, like some of you haven't on this webinar, this is going to talk you through it step by step how to use the algebra tiles. And I've just enlarged it here for you. So we can see that this represents 5a minus 3 plus 2a plus 5. And then this helps us simplify this expression. We can bring our x's together. So we can see we've got our a's, sorry, not x's. Bring our a's together. So we can see we've got 7a. And then our negative ones and positive ones are going to come together to make a 0 pair. So to simplify this expression, we are going to end up with 7a plus 2. And you can see there how the algebra tiles are showing what we might do to collect that. I'm sure some of you have come across the misconceptions where students will just together and simplify incorrectly. But using these algebra tiles is really going to help them not mix up the 1s and the a's in this example. And then similarly in the next one here, we've got x squareds, and we're starting with x squared plus 2x plus x squared minus x. And again, our positive x and negative x are going to come together to make a leaving us with the expression 2x squared plus 2x. So a quick example there from the books that shows us how we might use algebra tiles to simplify expressions. Now you're going to have a go now with our interactive tools. So I'll put the link in again, just in case anyone's missed it. So make sure you just click on this link so that you can get access to the digital tools. And examples together so you can get used to using this tool. I think it's a really good way of doing it. One, if you haven't got the actual algebra tiles and maybe your school hasn't got the budget to buy them, or you're a bit worried about using them with your classes, this is a really good tool that you can get up on screen, or you can even get the pupils using it on their own laptops or iPads to help them with simplifying expressions. So we will move on, and we're going to go through these couple of examples, okay? So I'm going to get the digital tool up now. Hopefully you've got it as well. Okay. Great about this tool is you'll see here we've got our algebra tiles, and at the moment they're labeled with x and x squared. But you'll notice our first example used b. So we can, so that we're not confusing pupils, we can change it. So you just go to the top up here and we can now label everything with B and B squared. And what we wanted to do was simplify 4B plus 2 plus B minus 5. So we're going to build that up now, just dragging across. So there's our 4 B's. I'm going to drag across 2. Then we're adding another B. And then to get our negative, we just need to press this down here and we've got our negative tiles. So we need minus 5. So you can build this as a front of class, or like I said, your pupils could be doing it on their own screen, or you might have the actual physical algebra tile. And then this is going to help us now to simplify this expression, because as we saw from the textbook, we can make 0 pairs. And now we can clearly see that that expression simplifies to 5B minus 3. Okay, so I'll just read out the next example. Oh no, I'll flick back to the other screen so you can see the other example, and then I'm just going to give you a couple of minutes to have a play about with this tool and see if you can simplify x squared plus 2x plus 3x squared minus 4x using those tiles. If you've got any questions while you're doing it, just pop it in the chat, or any comments, pop it in the chat. So I'll give you a couple of minutes to do that one. Remember, when you've got your 2x's and your negative 4x, to make your 0 pairs, you just need to drag them on top of each other. Okay, great. Right, so hopefully you had a little play about there with your tiles. Did everyone remember to turn it back to X as well? This example, we were using X's instead of B's. And if there's any questions on that, just pop it in the chat. But we're going to have a look next at brackets. Okay, so again, we're going to go back to the textbook now, and you can see here a really clear example of how we can use algebra tiles to expand a bracket. So we've got 4 lots of x plus 3, and we're using an area model to represent this. So we've got our 4 1 tiles on the left hand side, and then we've built x plus 3 along the top. And then we can see quite clearly that the expanded form of this gives us 4x plus 12. So a really clear example there from the model and reps part of the textbook. And a bit further in the next example in the textbook, we can see how we can expand brackets using algebra tiles with negatives. So this example, we're expanding 5 lots of a minus 2. We've built 5 on the left hand side, and then we've got our x minus 2 along the top. And this is going to give us an expanded form of 5a minus 10. Now in the books, the next step for question 1, as you can see, has this little cube symbol here. And what this is doing is recommending to the teacher that we've just gone through the examples using a concrete manipulative. So I recommend that you use this with your students as well. And you could, like I say, use the physical algebra tiles or use an interactive tool like the one that we use. So I'm just going to, again, demonstrate how you can use the tool to do this sort of thing, and then I'll leave you to have a go at some of the other questions. So I'll tab back to my tool. Okay, so this time we're expanding brackets. So we'll just clear all on here. And what you need is this second little tab on the side. So I'll put that one away, bring this one out, and we're going to use this tool here that looks just like it did in the textbook. Our first question was 3 lots of x plus 2. Okay, so we're going to build that up. I'm going to change it to x. There we go. And I need to go back to my positives here as well. So we're going to build 3 down this side. And then we're going to build x plus 2 along the top. Now we could fill this in one by one if we wanted, depending on how we're demonstrating to our classes, or we can just press the little green X and that will complete the expansion for us. So we can see that 3 lots of x plus 2 is equivalent to 3x plus 6. Okay. Any questions on that? 'Cause I'm going to need to do some now. Okay, right. We'll go back. Just have a play about again with that interactive tool on some of these with the negatives C and D, and I'll give you a couple of minutes to have a go at some of those. Yeah, and Ian's just adding a nice little comment for us. Yeah, it really helps prevent students writing things like 3x plus 6 and 9x. Yeah, because they can absolutely see that that's just not the case when they're using a representation like this. Please do just say if you're getting stuck, you're not sure where to click on your screen. I can go through another example. Okay, hopefully you've done at least one of those, or maybe you've done all of those, had a little play about. I'll keep an eye on the chat to any questions, but we're going to move on now to double brackets. Okay, so I'm going to demonstrate an example on the slides, how we could use algebra tiles with double brackets. Then after this, you'll have a go at a couple on the tool. Then finally, we'll do some factorizing and I'm going to hand over to Ian. Okay, so we're going to expand x plus 1 multiplied by x plus 2. Okay, so this is what you'd have on your tool like we've just used with the single brackets. We're going to build x plus 1 on the left hand side. So we need an x tile and a 1. And then x plus 2 along the top. So we need our x tile and 2 1s. Now, like we did before, you could either press the little green X in the corner or you could build it individually. But students will be able to see quite clearly here that this expands to x squared plus 2x plus x plus 2. And then from the work we did earlier as well, we can simplify that to x squared plus 3x plus 2. Okay, so really simple. It's just like multiplying out a single bracket. We use that same technique with our double brackets and help pupils see what's going on there. Here's a couple of you to just have a go at. Again, a couple of minutes using that tool. You've got one with 2 positives and then one with a positive and a negative. So you're going to have to be pulling them together to make your 0 pairs when you're simplifying those. I'll give you a couple of minutes. If you get finished early, do feel free to just comment as well if you're thinking this might help your pupils or anything they might find confusing. Just pop it in the chat. We'll always find feedback really interesting on things like this. Oh, that's great to hear, Nick. I'm glad that they've been useful with your year nines. What topics have you used them for out of interest? Okay, hopefully everyone's had a good go at those two. That all the way through. Any questions, let me know. Any comments, let me know. But we'll just move on to factorizing. Oh, Ian, can you just read that out, that comment?
Yeah, Nick's just saying that she's been using them with collecting like terms and expanding brackets. So the same sort of things. And, they've been a lower retaining group. And in the past, they've struggled with it, but they've really getting the hang of the concept through using the concrete manipulatives, which is great. And Claire's used them from completing the square as well, which is, a real abstract topic, which can be made real using the algebra tiles. So that's really good to hear.
Yeah, I love them for completing the square. I'm not covering that today, but if you've not seen it, well, I'm sure you can imagine now how it could work, but it's really good. I remember when I learned it at school, I didn't have a clue what was going on, but as an adult using algebra tiles, I was like, wow. Anyway, let's move on to the last section on factorizing. So again, a little extra up to show you how if we weren't doing this webinar now, you could still use the textbook to help you understand how to use a manipulative like this. So here it's telling us that if an expression is made as a result of expanding brackets, then the original expression with brackets, for example, 6x plus 9. So we've got our 6x and we've got our 9 tiles just randomly. And what we need to do is arrange them as a so we're going to take our tiles and arrange them as a rectangle, and then we can see the dimensions of the rectangle. So we can see that this has got dimensions 3 and 2x plus 3. So we therefore know that 3 lots of 2x plus 3 must be equivalent to 6x plus 9. So we can see here how the algebra tiles can help us factorize. Okay. So we'll have a little look at an example, a bit of a harder example here, x squared plus 3x plus 2. So we get our algebra tiles, random order, and our job, or the pupil's job, then is to arrange these into a nice rectangle. And that can be a nice little problem solving task in itself. But here they arrange as a rectangle like this. So we can see then the dimensions, and we can see that we've got the top as x plus 2, the side as x plus 1. So x squared plus 3x plus 2 must factorize to x plus 1 in brackets x plus 2. Okay, so it's a really nice way for students to explore factorization. I know this is a topic that a lot of students find a little bit tricky. So again, final task for you. There's some here for you to have a go using that tool to factorize. So you just need I'll go back, but you don't need this time. So you can clear all, and all you're going to need is these tiles. Get them out and then have a play about arranging them in a rectangle. Go back to your questions. And I will show you the answers for these ones as well. And then we'll move on. Is there a quick way of getting 9 squares? I think there is. Let me just have a look. Clear all. So if you get 1, and then this button here at the top, we'll just duplicate it. The only thing that annoys me a bit though is that then I want to rearrange them. How many have I got? 3, 4, 5, 6, 7, 8, 9. Oh, good guess. So yeah, you can pull one out and then you can duplicate. as many times as you want. Hope that helps. Okay, I know I've not given a long time, but I'm worried I don't want poor Ian to have to rush at the end. So I'm going to go through the answers to these. So either carry on playing with it while I go through the answers, or you can just watch the answers. But we were factorizing 9 plus 3x first. So there are tiles arranged as a rectangle look like this. So we can see that it factorizes to 3 lots of x plus 3. So hopefully you all got that one. Next, factorize 5x plus x squared. Here's our tiles. This is how they arrange as a rectangle. So we can see we've got x lots of x plus 5. And then finally, we ramped up the difficulty here with 2x squared plus 7x plus 6. Here's our tiles. And arranged as a rectangle look like this. So that must factorize to 2x plus 3 and x plus 2. Okay, so there's loads of other ways we could use algebra tiles, but they were just a quick few, some of my favorites. And hopefully that's given you a really good idea of, one, how the books could help explain how to use a tool like this, and then how you can use free things like this tool that I've shared with you today to demonstrate to your classes as well. So I'm going to hand over now to Ian. I'll stop sharing so that he can share his screen, and I'm really excited about this part on geometrical reasoning. So over to you, Ian.
Thank you very much, Caroline. I really enjoyed that bit of algebra exercise too. Always gets me thinking, does that? And yeah, really, really useful in the classroom, really helps students to understand, which is what this is all about. We're also looking upskilling ourselves as teachers, because, you know, some of you said you'd never used them before. Some of you said you'd only used them a little bit. And, you know, this sort of working together, you know, as we are now in a webinar, or as you can do with your department, is really, really important to help develop our teaching styles, so that will help the students to understand even further. And what we've tried to provide in White Rose Maths as a whole, all the materials we provide for free in the schemes of learning, but also within the textbooks, is lots of opportunities for people to work together to develop their understanding of things like algebra and also geometry, which I'm looking at now. So I'm not going to give you any fancy whizzy tools, but I'm still going to expect you to do some maths during this session. So to start with, just a quick true or false question. And again, you know, that's deliberate. We've got lots of true or false activities in the books, and you know, the idea of that is to get students thinking. It's not just something that's definitely true, something that's definitely false, something that, you know, gets their creative juices going. So here's a question for you then, a geometrical one. So if you have two straight lines, then either they're parallel or they intersect at exactly one point, and there's no other possibilities. So I'm going to give you 30 seconds or so to think about that, and then can you just add your thoughts into the chat box, please? Just T or F is all you need to type in. Oh, someone's got in there straight away. Okay, I've got one vote for that. Don't worry about getting it right or wrong, it's not the point. What is your first thought here? Okay, I've got one vote for false and then some trues, but the intersection might not show. Okay, interesting. Thank you very much. Again, something like this, I find incredibly difficult to do in my head. I'll straight away, I want to get a piece of paper, I want to get a pen, I want to draw lines, or I want to get out some concrete manipulatives to work on it. And something you can use for this one is pencils or straws. So you can get your two straws to represent your lines, and yeah, you can get them to be parallel. That is one possibility. You can also get them to intersect at one point. That is another possibility. There is actually a sneaky third possibility in this case, because if you get one of your lines or your straws or your pencils, whatever you're using, and you get the other one to fit exactly on top of it, it could be the case that they are actually the same line. Okay, so that's a sneaky third possibility, which you wouldn't probably think about if you were just drawing it. But when you're moving the things around, using that concrete pictorial abstract approach to mastery that Caroline was talking about, then you might see putting them on top of each other as another possibility in there. Okay, another thing I want to point out here is that language I've been using. I said, if you have two straight lines, I think one of the delegates pointed out that, well, you might not be able to see the intersection depending where the lines are. And that's really important in terms of, again, mathematical language. So two things here, a line and a line segment. So what's the same, what's different? Again, another interesting conversation to have with students or amongst your department, particularly if you're looking at non-specialist teachers, which a lot of us have in our departments, might not realize the fine distinction between those two things, that a straight line goes on forever in both directions, a line segment is part of a straight line. But we use this language all the way through our textbooks and all the way through our White Rose schemes that match the textbooks right from the beginning. So I'm in here in chapter 11.1, the very first geometry chapter in the first book. And straight away, we're looking at words like line segments, and we're looking at geometrical notation and how we use that. And we practice that, we take that further a little bit later, looking at that three-letter angle notation. So really things that students, might get confused by, things that often do cause difficulty in examinations, we're going straight away in for, not leaving that to be something tacked on at the end when there's already an awful lot of stress around looking for exams. So it's all really about progression and progression in understanding through the series. So in the first book, that's what we look at in terms of geometry. We look at that construction and understanding that notation and angles and looking to begin to understand with geometrical reasoning. You'll notice there's some H's on there. They correspond to what we call our higher steps. And our higher steps in Key Stage 3 do come back later in Book 2 and Book 3 as well. It's not about higher GCSE content at this stage, but it's just something that you might want to give some students as a bit of extra challenge, or something for students who need a little bit more support. You're going to leave and cover those in later years. So for example, in there, you can see there's angles and parallel lines as a higher step. But when we go into the Year 8 section, you can see that angles and parallel lines come in with a whole block of their own. Again, constructing bisectors is a higher step in Year 8, but it comes in one of the two blocks we have on geometry in Year 9. And again, we take it much, much further, looking at deduction. So we really progress all the way through the Key Stage 3 curriculum as we go through the books. Also, there's a progression of demand within each book and within each chapter. And some of the things I'm going to show you tonight are going to be pretty challenging, even though they're all from the first 3 chapters in the first book. But there's plenty of maths in there to get your head around. So, as I've mentioned, first thing, understanding and using notation. Also, mathematical vocabulary and using that correctly. the use of concrete manipulatives, as Caroline demonstrated, to help with understanding, as we did with that first task as well. And within every chapter in the book, we've got this section on models and representations showing what you can use. So, for example, you can use just objects you've got in the classroom, like pencils and rulers. You can make angles with parts of the body. You can use geostrips or make your own geostrips out of strips of paper and paper fasteners in order to make shapes and investigate properties. We can take that a little bit further later on, using set squares, using geoboards, etc. So there's all the ideas there for you to share with your students, and again, to work with in your teams as you're developing this knowledge of the mastery approach yourself. What we're aiming to do is make connections with different areas of maths. For example, by the time we get to book 3, we connect those constructions of bisectors with properties of shapes and where they come from. And really, we're looking at developing the levels of reasoning from the students. So they might start off with some very simple reasons, just what they see, how they see it, until they get to more formal proof by the end of year 9, preparing them for Key Stage 4. Everything we do in White Rose Maths is based on extensive research, and there was some research by Van Heil way back in 1986, which looked at this idea of different levels of reasoning that students have in geometry. And level 1, he talked about using visualization, non-verbal thinking, just by recognizing things. So why is that shape a square? A student might just say it is because it looks like one, and not actually look at properties. Is that actually a square? Well, without the correct notation and the size labels, we don't know if that's exactly a square or not. So we want to get beyond that stage and looking at describing properties of shapes in there in a little bit more detail, okay? Explaining why it's a square because it has sides of equal length, justifying it. Then making those connections and relationships, understanding that all squares are rectangles. They're just better than rectangles. They've got all the properties of rectangles and a little bit more. All squares are also parallelograms, etc. And finally, we get to that higher level deduction where you get in a formal proof step by step by step. And we're trying to work through this progression of demand all the way through in every single chapter, not just the progression through the series as well. Okay. One of the ways we do this is through our thinking questions. So every section of the book has a section that's called What Do You Think? So this first question here, rather than talking about the similarities and differences between a kite and a delta, we get the students to think about it and then describe them. Okay, so a delta is shown there, a kite has already been covered, and then they can look at, well, what's the same, what's different? So that question, I've already used it once tonight, occurs regularly throughout our books. What's the same, what's different? Beginning for them to develop those reasoning skills. Again, the second question, are these questions true or false? Are each of these statements true or false? I mentioned earlier, a true or false is another really good way of getting students to think. And as I've just said, all squares are rectangles, but obviously not all rectangles are squares. So why is that the case? How can I draw examples to show that, not just talk about it? The third question I've got at the bottom there, again, uses another of my favorite concrete resources, a geoboard. So how many different quadrilaterals can you make on a 3x3 geoboard? And decide what you mean by different as well. And I think that's a key thing that sometimes we don't talk about with students. So for example, here's a couple of 3x3 geoboards. I've drawn 2 rectangles. Are they the same? Are they different? You might want to just go, well, they're the same, they're congruent, but they are different as well because they're in a different orientation. So again, having those discussions around same and different is very important. Here's another set of shapes I can make on that 3x3 geoboard. And you can use dotty paper as well, of course, if you haven't got actual geoboards. And again, all those shapes, you would probably naturally say they're different because they're different sizes and they're different areas. but in some ways they're the same because all those shapes are squares. They're just squares of different sizes. And again, the last one is in a different orientation. And a lot of students may leap to the misconception that that is a diamond. Well, it's not a diamond, it's just a square in a different position. And again, our key thing, what we're trying to do is get students to think about the properties and recognize the properties rather than just learn a big list. A square does this, a rectangle does this, a kite does this. If you're making the shapes, then you're thinking about the shapes and you're thinking, what makes a square a square? What makes a rhombus a rhombus? Why is it that on the 3x3 geoboard, you can't actually make a rhombus? You need a bigger geoboard to be able to do that one. So here's another sort of question like the ones we've got in the books. I've got some of those shapes there and that I've made on the 3x3 geoboard. And the question I'm just going to ask you, another quick one, just which one doesn't belong and why? So I'm just going to give you again another 30 seconds to a minute just to think which shape is the odd one out and why. So just type a letter and maybe if you've got quick fingers, type a reason as well for that. Again, there's more than one answer to this, so don't worry about getting it wrong. That's not what it's all about. Okay, so lots of people going for B. This is the only one that's a parallelogram. The others only have one pair of parallel sides. Okay, perfectly reasonable answer for that one. Okay, could you think of another one apart from B for being the odd one out? Lots of people have gone for that reason for B. The others being trapezia. Okay, Caroline thinks D is the odd one out. Why do you think D is the odd one out, Caroline? And she's muted.
Sorry, I just unmute. Because it uses more than half of the grid.
It's the only one that uses more than half of the grid, exactly. And again, you can make links with other areas of the curriculum, like making links to fractions there. And F. Jones is telling us that A has a line of symmetry and the other ones don't, etc., etc., etc. Okay, all sorts of reasons we can say for that one. Another thing you can say, which two shapes have the same area? Convince me. Justify your answer. Again, building up that idea of not just visualizing and seeing that things look equal, but how can you justify? So the ones that do have the same area are actually C and A, and you can see they're made out of 3 of half little squares in there. So another really, really good tool, geoboard, dotty paper to get thinking going and get reasoning going. And this sort of activity, I mean, we're doing it now as adults and enjoying it, at least I hope we're enjoying it. It's something you can definitely do with your team to sit down and think about, right, what can we see? What can't we see? How might this work in class? What might they think? What might they not think, etc. Another question there, do any of the shapes have the same perimeter? And you can start thinking about, the different types of lengths and maybe linking this into algebra. So this, calling the straight unit here X and calling this Y, etc. And looking at ways you can describe the perimeters. Here's another question from the textbook, again, right early on in the first couple of chapters where we're just looking at what shapes names are, and copy each diagram onto dotty paper and join to make the shape. So rather than name this shape, what is this shape type of questions, real ones that get them thinking. Now, I have to say, I find these quite challenging. I can't visualize this in my head. Where am I going to get the rhombus? Where am I going to get the square? But once I've got it drawn out and I've got my pencil to play around with, then I can start to make those shapes. And obviously, again, the shapes are going to be in non-standard orientations. I was looking at this earlier thinking, oh, that would be an easy question to present. And I was looking at it thinking, oh, I can't see where the rhombus is. It really is quite difficult, because my first thought was to make the rhombus by going down in the same sort of way as the first line. And square is a special rhombus. So the rhombus I'd make by going diagonally down over there. Okay, lots of things again to think about to really develop understanding of what the shapes are and what makes the shape that particular shape. We carry on with that in the same kind of exercise. Draw a sketch to show how you can split this hexagon into 2 rectangles, into 2 trapezia. Okay, so again, straight away we're looking at the language. That's not an L shape, that's a hexagon. It's got 6 sides, so call it an hexagon. You would normally split this into rectangles, perhaps to find the area, but you can split it down diagonally to split it into 2 trapezia instead. And then that part B, which really challenges, what other shapes can you make by joining pairs of quadrilaterals? Can you make an octagon? Can you make a shape with 7 sides? It depends what quadrilaterals you're working with. And then the more you're working with them, the more you get familiar with the vocabulary and remember the names. I've known lots of students who in year 11 don't know the difference between a rhombus and a parallelogram. But working with them in this sort of way, playing with them, investigating with them, really helps to develop that understanding of what they are. Again, another challenge from the same exercise in there, looking at that word hexagon, presenting hexagons in non-standard ways. A lot of students would only recognize C and perhaps A as being a hexagon and might not think that many of these other ones are. Another open question here that really helps develop reasoning. Draw a pentagon with no right angles, 1 right angle, 2, 3. And you might think to yourself, well, why does the question stop at 3? Well, why can't we draw a pentagon with 4 right angles? And yeah, that's a really good mathematical activity to get involved in and to think about as well. All of those are from the basic sections in our chapters, but we also have in every chapter at the end stretch questions, which really do deepen learning and really get that understanding going by thinking about some more challenging mathematics in there. So in this first one, why is it that a triangle can't have a pair of parallel sides? You know, that's quite a difficult thing to do, but again, by drawing and talking together, students can get that understanding. The second one, Emily is talking about the shortest side of a triangle is opposite the smallest angle. Is that true or not? Gives you more practice at constructing triangles and working on those in a more interesting concept than just drawing a lot of triangles for their sake. Also, that links forward. Later on, they need to know that the longest side of a triangle is opposite the largest angle, particularly for Pythagoras' theorem when we're looking at the hypotenuse. And that's, you know, an interesting fact to investigate for students as well. Plenty more in this same exercise. I'm going to look very briefly at number 4, looking at the difference between convex and concave polygons, something we probably don't talk about very often, but again, really helps think about understanding why is it you can get more right angles in some and not in others, etc. Really helping to understand that. And we also talk about things like, you know, using the set square, using the equipment to use things to construct things, particularly constructing parallel lines, perpendicular lines, how you can use them to construct angles as well. Just on that one, I'm going to show about using a set square to get parallel lines. Often when I'm drawing parallel lines, I just get a ruler out and draw either side of it, and there they are, they're parallels, providing I've got a good ruler. If I want parallel lines that are different distance apart, I've got to move my ruler down the page, and that can leave maybe, you know, to a little bit of error, and they're not necessarily parallel. So in case you've not seen this before, you can use a set square by putting it on a ruler, draw a line on one side, and then move it along the set square, and the second line you draw is going to be parallel to the first. And then your parallel lines don't all have to be 1 ruler width apart. They can be any distance apart that you want to. Again, if you do that at an angle, you can make your parallel lines be any angle and at any distance apart as well. Okay, so just to let you know where you can get further support with ideas for this is developing geometrical reasoning or developing algebraic reasoning, as Caroline was talking about earlier with algebra tiles. The textbooks do have a series of teacher guides. So behind the questions, goes through every single question in every one of the books, tells you the purpose of that question, tells you some ideas for supporting students with those questions as well. Also talks about things to look out for, common misconceptions, and how to deal with those. It goes through the models and representations for every chapter as well. So that's one resource. Our own White Rose Maths Schemes of Learning, as Caroline has mentioned, completely free online. If you go on our website, you click on the block, you get our Schemes of Learning for the block. Within the Schemes of Learning, we talk about these key representations, what things you can use to support each of the topics, and also for every single small step, some exemplar questions, ideas for teaching, some key questions, and some key vocabulary as well. There's also premium resources, so some more worksheets, more true or false questions that you can buy for a very reasonable price that accompany and match our schemes and textbooks exactly. And then what I just talked about, that parallel lines, that's an example of one of our secondary snacks, which is part of our curriculum professional development package. So lots of CPD on our website as well that you can get on demand. You can watch on your own, webinars or face-to-face events as well. So all sorts of further support available via our website. And so I'm going to pass over to you now and ask any questions. Cassie has just put in a link for the evaluation pack for the textbooks if you don't have those already. So thanks for that, Cassie. I'm aware we're pretty close to the end of time. I think we did very well there, Caroline, 57 minutes, but we have left a couple of minutes for questions if anybody's got anything burning now, or Caroline, if there's anything I've forgotten to say that you'd like to add.
No, I don't think so. No, I really enjoyed that, Ian. Thank you.
Yeah, I enjoyed yours too.
Any questions at all? Yeah, just let us know, and hopefully you'll get the books and love them. Oh, thanks, Nick, and thanks for the Twitter request. I think it's you. Thanks, Dawn.
So can scheme of work and the resource be used with other textbooks? Yeah, if it covers the Key Stage 3, then that's absolutely fine. Yeah, our scheme of learning covers Key Stage 3. You can use whatever textbook you like to support that. The thing with the textbook is it is written in the same style and in the same way, well, by the same people, essentially, by the same wider team, that matches that idea of mastery. So not all the textbooks have that. Do you have to get the books alongside the White Rose resource? Not necessarily. So, you know, you pick and choose what's suitable for you. I can see a question about how long are the exercises. I'd need more practice than on the worksheets. There's a lot of material in each of the exercises, as well as the first section of, you know, standard questions. We have a consolidate section for students that might need more practice, and as I've already mentioned, there's the what do you think questions and the stretch questions as well, and they obviously are designed to be much longer, you know, take more time and take more thought. So I certainly don't think you're likely to run out of material on those ones. Have I missed any questions going up there, Caroline?
No, I think that was it.
Okay. Yeah. So the Cassie has just posted in another link for that. If you want to ask any further questions to Collins, you can also email us directly, whiterosemaths.com, support@whiterosemaths.com, if you have any questions that are specific to White Rose rather than specific to the Collins textbook, then feel free to contact us there.
Great, thanks everyone.
Cool.
Okay, thank you everybody for coming.
Thank you both.
Thank you.
Okay, thanks very much. Have a good evening, everybody.
Bye.